there's a reversal. Now the magnetic field is outward in the northern hemisphere and inward in the southern hemisphere.
So now the burning question is what's happening in Gary's model reflected in the real Earth? Is the 300-year decline in our field, which the pottery reveals, the work of magnetic anomalies brewing deep in the core beneath our feet? If so, then a reversal really could be in the cards.
If the north isn't true, will I lose my way to you?
Amazingly, there are detailed records that cover exactly this 300-year period. The logbooks of Her Majesty's Navy. For as geophysicist Jeremy Bloxham has discovered, 18th and 19th century sailors were obsessed with the magnetic field.
Back in the days of James Cook, when he was doing his voyages of exploration, a compass was the primary means of navigation. However, a compass needle doesn't point at true north, at the real geographical North Pole. Instead, it points at magnetic north.
For sailors, knowing the difference between true north and magnetic north was a matter of life and death. But as they were well aware, magnetic north keeps moving, wandering about near the pole as the field gradually changes. So navigators needed to measure the difference between magnetic north and true north, the angle of variation. They did this by comparing their compass bearing to an astronomical calculation of true north.
The trick was to find true north, and they could do this by looking at the sun at noon when it's highest in the sky, alternatively by looking at the angle the sun made at sunrise or sunset. Here on the 8th of June 1770 we have a magnetic variation of 4 degrees and 53 minutes east.
Thousands of these observations, together with early measures of the local strength of the field, have enabled Jeremy to reconstruct the ebb and flow of the Earth's magnetism over the past 3 centuries. And it's what this reveals about one region in particular that's significant.
We've seen very abrupt changes in the Earth's magnetic field beneath the South Atlantic Ocean.
Beneath the South Atlantic, Jeremy has found clear evidence for a region of magnetic anomalies, places where the field has already started to reverse. And these anomalies are growing.
As we get into the beginning of the 20th century, we see the emergence of a new patch of reverse flux, a region where the field lines, instead of coming out of the core, are looping back into the core. And that patch then drifts towards the west, hooking up with this other patch of reverse flux to create a large region, what we call the South Atlantic anomaly, where the field is about 30% weaker. And that patch has grown substantially during the last 100 years in particular. So one question we're all asking ourselves at the moment is the Earth's magnetic field about to flip?
In a region of the core 2,000 miles beneath the South Atlantic, the magnetic currents have reversed direction, canceling out the main field, causing its strength to decline. If things continue like this, then we could experience a magnetic phenomenon the Earth has not seen for 780,000 years. A complete flip of the entire global field.
There's really no question about whether the Earth's magnetic field will reverse again. The question is not if that's going to happen, it's when that's going to happen.
Actually, in the last few hundred years, the intensity of the magnetic field on the Earth has been decreasing, which is an indication that maybe we're in for a reversal. The average time between reversals is on the order of a few 100,000 years. We're actually sort of due for one.
No one has ever experienced a magnetic reversal. If this is really the beginning of a flip, what exactly will happen next? one man who may know is geologist Rob Coe. For 25 years, he's been coming to Steens Mountain in Oregon, a vast heap of hundreds of ancient lava flows.
"16 million years ago, there was a huge series of eruptions here. You can pick out literally hundreds of lava flows over on that wall. Each line delineates a different lava flow. It's over 3,000 feet of overlying flows.